Hello everyone, and welcome to SlashData's latest webinar, presenting key findings on machine learning developers and their data from our Q1 2021 global survey, is our very own data storyteller, Jed Stevens. My name is Steve McCann, and before handing over to Jed, for those of you less familiar with SlashData, I will provide a quick overview of who we are and what we do. So SlashData is a developer-focused analyst company, and we help developer-focused orgs better understand developers using a data-backed approach. Here you can see a quick snapshot of some of the orgs that we work with. And this slide presents a good overview of the research behind today's presentation and many of the reports and interactive data dashboards that SlashData produces each year. We consistently capture developers' experiences in the 11 development areas you can see on the left. It's important to note that these are not distinct people or separate surveys. Developers tend to work in multiple areas. There's much overlap, and our survey approach captures this cross-area experience. We run 2 global surveys each year, pulling the responses of more than 30,000 developers annually, reaching developers in over 150 countries and 8 languages beyond English. Therefore, providing a truly representative sample of the developer community. And in this rapidly growing and evolving space, we reach developers where they are, and we do this through the 80+ partners and channels. That's everything from paid media to developer communities to Slack channels, language communities, etc. Some of those may be local or regional, others global. And they range from everything from student communities to professional developer forums, as well as vendor communities. And with that, I will hand over to Jed for today's presentation.
Thanks, Steve. Let me tell you about today's presentation. It's titled Machine Learning Developers and Their Data. It draws from the State of the Developer Nation, the 20th edition. Today's talk is going to look at the types of data that machine learning, AI, and data scientists work with, how many machine learning, AI, and data scientists work on each of these different types of data, which data types are frequently used together, the mixture of professional, hobbyist, and students in each of these data types, industry application areas, so which industries are using which data types, and the size and structure of training data that ML, AI, and data scientists use. We'll bring it together with some key insights. We use the acronym ML, AI, DS to denote machine learning, artificial intelligence, and data scientists, who we group together for this analysis. This is an overview of the types of data that we see these group of developers use. Right up, what we can see is that text, unstructured data used by 68% of these developers is the most popular data type. It's relatively closely followed by tabular data, with 54% of developers using tabular data that involves no simulation, and an additional 5% of these developers using tabular data that involves some simulation. 92% of the tabular data that is used is therefore observed data, while only 8% is simulated. The 2 most common use cases for this data, the simulated data, is workforce planning and resource allocation, both areas accounting for at least 40% of the use of simulated data. It's a fairly slow cutoff between text unstructured all the way down to audio. And of course, video data is essentially a live stream or a continuous interlock of images and audio. We'll see how these interplay fairly shortly when we look at what sort of data types these developers use together. Okay, so we know what are the popular data types. We know the percentages who use each data type, but how many developers are out there using each of these different data types? Well, that's what we answer here. So I want to start by bringing your attention to this figure over here, where we plot the size of the ML AI DS community over the last 4 waves of our survey, from Q3 2019 all the way up to the latest one, which we're drawing this data, Q1 2020. We found that in Q1 2020, there are 15.3 million ML, AI, and DS developers. This is 12% growth from a Q3 2020. Between Q1 2020 and Q3 2020, there was only a 3% growth, so essentially 0.4 million ML, AI, DS developers added. We expect this growth to be relatively constant now. We see in other of our reports indications that the ML, AI, DS community is starting to become increasingly professional, maybe exiting out of the exponential growth that it had in earlier surveys that we observed. However, some of the slow growth here could definitely be accounted for by COVID-19 related uncertainties. And so in this slightly post-COVID-19 period, it's not entirely surprising to have observed the 12% growth. What does it mean for the number of ML, AI, DS developers working in each of these data types? Well, we see 10.4 million developers working in text unstructured, 8.6 for images, 5.8 for video, 4.7 for audio, and then finally our tabular data, 8.2 million. Altogether, one of the surprising results, one of the results that some of our clients have found surprising, is the generally high proportion of developers who are working with text unstructured data. This may be surprising on the face of it, but as we dig a bit deeper, it will become more and more obvious why this is and why tabular data is coming second. So let's look here at the usage combinations of the different data types. We know that 68% of ML, AI, DS developers use unstructured text data, and that's the most common type of data that these developers work with. However, developers frequently work with multiple different data types, and it's audio over here that is the most combined. Before I get into the detail about it, let me explain how we read this figure. We start up here by saying that you're given that you are using either images, video, text, audio, or tabular data, including simulated data. And so if we know that a developer uses audio data, we know that 77% of those who use audio data also use images. Similarly, 76% who use audio data also use video. And in this way, it's pretty easy to see when we compare the size of these bars against all the other bars that audio is the most frequently combined data type. 75 to 76% of those who use audio data also use images, video, or text. And given the popular applications of audio data, that being text-to-speech generation, 47% of developers who work in audio data work in that application area, speech recognition, 46%, as well as the strong overlaps of video and text data, it's not entirely surprising. Image data, like audio data, also heavily overlaps with video data. After all, videos are simply streams of static images. And that's why the 78% who of those using video data also use audio data. 78% of those using video data also use image data. Now, if we look at it the other way, what we call the reverse dependency, so that is when we look at those who use image data and want to look at how many use video, and text, and otherwise, it's not as strong. Only 52% of those who are analyzing images also analyze video. So this is opposed to, if we have a look here at video, those who analyze images. And so we know from this immediately that those that are working in images may be just working in images. There's a fair proportion of these MLA IDS developers who do not interlap between the two. The top application areas of both image data and video data are image classification and facial recognition. And these two key application fields are driving the next generation of intelligent devices, improving augmented reality in games, underpinning self-driving cars, in home robotics, home security, as well as medical imaging technology. Clearly hot topics. But what about our all-time favorite? Tabular data, the one that started it all off. Well, structured tabular data sits almost to the side, which is why we've shown it at the bottom row of the previous two figures. And it is the least likely to be combined with the other data types. Although uncommon to combine this data type, tabular data, with audio or video, there is a very strong overlap between those who use tabular data and also use text data, 69%. And unsurprisingly, when we dig a bit deeper, the top application for both tabular data as well as unstructured text is the analysis and prediction of customer behavior. And this is just the sort of analysis that often is done on the data nuggets we leave behind when searching on retail websites. And these are key inputs to algorithms for natural language processes as well as recommender systems. So hence strong interlink. And also, if you're working in text data, although you might have good overlaps with others, one of the strongest or the strongest overlap for our tabular data. So if you are working in text data, this is the other field that both dependencies are relatively strong on one another. Okay, that's about what data is used together. But who's using this data? So what we're looking at here is a figure that gives us the breakdown between professionals, students, and hobbyists. We ask, these are self-identified terms, and a developer could self-identify as one or three or any combination of these three terms. In order to get a clearer picture for this analysis, we've teased them out. So we've denoted those who've identified as exclusively professionals. Professionals who say that they are either hobbyists or students. It's coming in there, this color. And then those who are exclusive students, exclusive hobbyists, or hobbyists and students, but certainly not professional, our final block. Professionals, as the word implies, are people who are working professionally, earning a wage, on project, etc. And the differentiation between hobbyists may be, we tend to see that hobbyists are people who would be typically working professionally in another field, but maybe they're not in this field. They are experimenting with it on the side. And students is a term that those who are starting to learn the field for the first time, as well as those who are getting into the field, perhaps from another of our 13 developer sectors, would use. The majority, 53% of all ML, DS, AI developers are professional, although they may not be exclusively, as you can see. Strong proportions here of professionals also identify as either a hobbyist or a student, but still, the majority, the 53%, identify as being professional. Of all the data types, audio, as you can see, this little white line denotes the distinction between professionals and non-professionals on our right. Audio data is the one with the highest proportion of professionals. Audio followed by video, tabular data followed by text, and finally images. And you can see also that these have some sort of relation to the proportion who are students, for example, images and texts. These are areas where we know there's quite a lot of new and current research, different algorithms, natural language processing, deep convolutional neural networks, etc. Larger proportion of students, suggesting, as we typically see, that these fields are a little bit further behind on their maturity or growth curves than some of the others. But it's a bit of a complicated understanding, and we will get into also understanding why audio and video tend to be more professional, and some of these are barriers to entry in terms of equipment. Now, the high proportion of professionals who are in audio tends to be this co-influencing, that audio is the most frequently combined data type, and also that professionals tend to engage with many different data types. Data types that are popular with students also tend to be the data types where there are more freely available data sets, especially in the image and tabular data sets where there are well-known practice as well as benchmarking data sets. Okay. We are continuing to paint the picture about the types of data, and this is a snapshot of the industries that ML, DS, AI developers work in. I'll explain how to read the figure in a second, but first let me say that here the rows are arranged from in the order of the top 10 most used industries for DS, ML, AI developers. So software products and services, essentially software development, SaaS, is the #1 industry that you would find an ML, DS, AI developer, followed by data analytics, education, etc., rounding us off in position #10 as manufacturing. Over here we have the columns: text, tabular, images, video, and audio. This time it's been arranged in exactly in the same way that the rows have been arranged, from most used to least used. So you'll recall text has the highest proportion of ML, DS, AI developers using it, all the way down to audio. What we have here is similar to the previous figure. Given that you are working with text, 42% who work with text are in software products and services. So 43% of ML, DS, AI developers who work with images are in software products and services. And this is the way you read the figure. In order to try and draw our attention to some insights, what we've done is we have colored certain cells according to deviations from the row average. So if we were to take the row average here, simply by adding up these figures, clearly it would be around 43. And as you can see by our coloring, we look for a deviation of 2.5 percentage points above or below the average before we assign it a color. And therefore you can see in data analytics, business intelligence, 30%, So given that you use text, 30% of MLDS AI developers are in this field, and so it is slightly below average. Similarly, those who are working with audio data, 24% of them tend to be in telecoms and networks. Now, what's important to note here is that if we take a step back, we see that actually developers who are working with each of these different data types tend to be roughly in each industry. Sometimes we can look at a figure like this and it tends out to look like a rainbow, very polarizing, but that's not what we're seeing here. And this is quite an important message, especially for our vendors, since if they are targeting certain industries, they need to realize that ML, DS, and AI developers tend to have in each of these industries, would have often different video, audio, and be using each of these different data types. So the products also need to reflect this. And while there's a lot of attention paid to data warehouses, data lakes, and which really focus around often our tabular or columnar data, the other data types could be overlooked. And this suggests that a more holistic view really needs to be captured. The other thing that it suggests is that it's not at least in the top 10 industries, there's not strong concentrations for a particular data type, with the exception of here telecommunications, which is clearly going to have a high reliance on audio, and the interlapse of audio will also push up the use of video. Now, we are gaining a better and better idea about the industries, the different uses of the data, who's using each. Next, let's try and understand, well, what are some of the barriers to entry? What are some of the sizes of the data that developers who are using these different data types would be working with? So what we've got here is we've got image data, video data, text data, and audio data. And we have asked these developers, how big is the data on disk? So that gives us an idea as to how much data they have, A, B, the sort of equipment constraints around them, and let's paint a more in-depth picture here. One of the take-homes is that larger data may not be as frequent as you imagine. And the hype around big data has left many with the impression that all developers in ML, AI, and DS work with extremely large data sets. The size of structured tabular data is measured in rows, but the size of the unstructured data, video, audio, and text, is measured on disk. And similar to what we observe for structured tabular data, our research also shows that very large data sets aren't perhaps as ubiquitous as one might expect. The most common band of data tends to be the 1 to 20,000 rows of data. This is, of course, for ML AI developers working with structured training data sets. And this does differ by application area. For example, 22% of those working in simulated data typically work with between 20 and 50,000 rows of data, while those working with optimization tools, who are obviously trying to find the best solution from a very challenging set of options, they tend to work with between 50 and 100,000 rows of data. And data set size also varies by professional status. Only 11% of professional developers use structured training data sets with up to 20,000 rows, while 43% of exclusively hobbyist and 54% exclusively students use this smaller data set below 20,000 rows. So this gives you a real idea that actually it's not big data just yet for the majority of those we are training, those who are learning, and as well as 11% of professionals. And this may have also to do with access to these data sets. Many companies generate large quantities of data as a byproduct of their direct business processes, which obviously students and hobbyists won't have access to. A further consideration is who has access to the infrastructure for processing large data sets. For example, those who are exclusively students might not have the hardware to consume large volumes of data. And non-tabular data is a useful measure for comparison between categories. So 18%, for example, of those who are working with image data are between 50 and 500 megabytes on disk, while only 8% of those who are working with image data exceed 1 terabyte. Now, this was on average. So the question was on average. So of course, they may be using one very large data set, but working on smaller ones. But on average, image data tends to be on the slightly smaller, or at least as you can see here, below the cutoff of 25 gigs on data. And if we just go through each of these, you can see with video, there's a more concentration on this larger data set, this up to 1 terabyte, as well as more than 1 terabyte. Audio, we see less of this. Video, of course, is the most intensive data to save. And text data, which tends to be more easy to save, not as large as image data, but still some very large data sets, but still under the 25 gig mark. Now, the reason this categorization was chosen is that it was designed to take into account processing power. So for MLAI developers, we expect that between 1 and 25 gigs of data could be handled by powerful, but not necessarily specialized hardware. Many developers in this could be reading it even into RAM memory. Depending on the language and the modeling method used, though, it's about an approximate upper bound. We see, though, that 26% of MLAI DS developers using text data and 41% of those using video data will require some sort of specialized training equipment. So that's when we're looking at bigger than the yellow bar. And this high level of specialization, it clearly creates a barrier to entry. And that means that data analysis on these large data sets is beyond, say, the achievable scope of those without deep back pocket funding or specialized cloud-based technology and infrastructure. We investigate all of these aspects, but for now, we paint an overview. And so this is an overview of what machine learning developers and their data looks like. I want to highlight some key insights from the presentation. What we saw today was that 68% of usage of unstructured text data is the most common data type, more common than tabular data. Around 9 million ML developers or data scientists work with tabular data, so not a small amount, definitely not going anywhere. Audio data is the most frequently combined data type. 75 to 76% of those who use audio data also use image, video, or text. Structured tabular data, though, is the type of data which tends to stand most on its own. And the majority, 53% of ML developers and data scientists are professional. Of course, taking into account where these could also be working or would be professional, but also say they're involved in hobbyist and student roles. 65% of those who are exclusively students use one or more data type, while 61% of those exclusively hobbyists and only 85% of those exclusively professionals use one or two data types. Very large training data sets aren't perhaps as ubiquitous as we could think. And while some industries use more data types than others, most industries use all the different data types. That is, we can find developers who work in each of the different data types in each of the different industries. And they wouldn't be there if it weren't for a reason. And 26% of ML, AI, DS developers use text data, and 41% of the, 26% of ML, AI, DS developers using text data and 41% using video data will require some sort of specialized hardware for their training needs. Thanks again.
Thank you, Jed. A really interesting view of the ML, AI, DS developers. Would it be correct of me to say that deeper developer data, such as the application areas that they target, different audiences that they target, or decision-making influences, for example, was also collected in the survey?
Absolutely, Steve. And if I can go on to say, industries that they work in, tools they use, methods of training, where they train it, all of these aspects are captured and more.
Fantastic. And I think from my own experience with some of our clients, the geographic distributions, population sizing, for example, of professionals or students also provide some really interesting insights.
For sure. And these are also aspects that we can provide and you can find in our reports.
Thanks for that, Jed. Much appreciated. And just before we close, folks, if you have any questions or would like to know more about our research, you can reach us through these channels that you see on the left-hand side of the slide. Also, I'd like to mention that our 21st global survey is currently live to the developer audience globally. And here you will see a link for those of you that would like to check it out. And the survey will be open until the 8th of August, 2021. Thanks again. Bye.